and that's by series. Hi Supriya, hello, very happy good evening. Hi Bhavya, hello, very happy good evening. So thank you so much for joining my session today. So please do like, share and subscribe. So Bhavya, I guess you didn't turn up for the session yesterday, but I hope you have watched the recorded lecture. Well, so we are in lecture 2, you can say, of the second topic in the chapter excretory substance and their elimination. So today we are going to talk about the mechanism of urine formation. So how is the urine made inside the kidney, and then how it is excreted is a topic for another day. So now we're going to talk about how the urine is being formed and what are the regions or what are the steps involved in this process. So that's what we are going to talk. So to begin with, so yesterday we were talking about the structure of the kidney. So I hope all of you are thorough with the structure of the kidney. So I've been talking about lately a lot of structures, right? So we started with the structure of the heart. So now the kidney. So I hope you remember all the structures because the structures are equally important. And the more you understand the structures, the easier it is for you, because this forms a base for your medicine also, you can say, for the first year of MBBS. So make sure you pay a lot of attention and you get done with the basics. Fine. So let's move into the mechanism of urine formation. So I guess you all are not new to this topic. So the mechanism of urine formation has 3 steps. So we are going to talk about those 3 steps in detail. So it's going to be a pretty crisp lecture. So I'm not going to extend much. So I'm not going to exaggerate. I'm not going to elaborate. So to the point, I'm going to speak, and we're going to we'll have the class for just 25 minutes or 30 minutes and not more than that. Fine. So before that, let me give you a recap of the structure of the kidney so that you have a continuity of yesterday's class. So I believe you guys after my lecture are going back and studying the NCERT. So you can say NCERT is like the Bible for NEET. So once you can go in and out of NCERT thoroughly, nook and corner of NCERT, so that is the perfect strategy to get or score good marks in NEET. So that is how I would say, and I would say it openly because yes, NCERT is what it takes to strive excellence. So please go back after my lecture and read NCERT, because now I'm taking mechanism of urine formation. So it is just 3 paragraphs in your NCERT, so that much I guess you will be able to do. So I'm not teaching the entire lecture, I'm teaching topic wise so that it is easy for you to complete every day's portion. So I hope you are doing that. And I also hope you guys are solving questions. So it's my humble request. So please solve at least 30 questions in each subject in NEET. So that is what is going to help you. So you have to train your mind to more questions than to a lot of theory. So you're not going to have theory. So even if you're a CBSE student, the CBSE term 1 is only MCQ, right? So train your mind or your brain to solve more questions. So, so your brain learns how to adapt to the questionnaire session or how to brainstorm to arrive at the answer. So that is what I want you to do basically. So every day I want you to expose yourself to a lot of questions. So the more the number of questions you solve, the better it is. But I would say the least would be 15. So at least 15 is mandatory number that you have to solve. So try solving. So pick up some time. So learn the art of time management. So that is beautiful thing. So once you manage time, everything falls in place. So please do that. So that is all the strategies that is required to make it successful. Only coming to my lecture, listening to what I speak is not going to help. So this is just 30% I can say. So 30% is to read your books, 30% is to solve questions, and 30% is to put it into application. So these are the things that I want you to make an amalgamation and work out, right? Hi Dharni, yes, a very happy good evening. So thank you for joining my lecture after a long time. I hope you're doing good. Yes, I'm good, thank you. So thank you once again guys for joining my lecture. Ma'am, 4 days holidays for us, Puja holidays. Okay, I guess it's Dashera. But yeah, so we are not breaking for any holidays. So since you guys have holidays, so it's the time that I should invest more so that I can connect with you guys more, right? So you guys are free from all the work, so I can connect with you more. So this is the time that I can talk to you, I can connect with you so you can get your doubts clarified. So no worries. So I guess they have changed the Telegram link, so please get in touch with the Telegram also. So we are here, so I will continue class for the next 3 days, so except Sunday. So we are not breaking for any holidays, okay? So without any further delay, let's move forward to talk about the mechanism of urine formation. So before we go, so let me recap the structure of the human kidney. So I hope human kidney is pretty clear. So we also spoke about the structure of the kidney and the structure of nephron separately. So I'll give you a quick recap as to what was the structure of the kidney, okay? You will be regular, okay? So let me take an attendance of how regular you are, Dharni. Yes? Fine. So the human kidney is bean shaped and it is located in the last thoracic cavity, and it's attached to the it is attached to the wall of the abdominal cavity. So your human kidney, so we have a pair of kidneys, so the size of it is 10 to 12 centimeter and the width of it is 4 to 5 centimeter. So then the thickness is 2 to 3 centimeter. So this is the kidney. So the kidney is covered by a tough capsule. So on the concave side of the kidney, no ma'am, telegram link has not been changed yet. Okay, so yesterday also I reminded them. Okay, today I will again remind them. So yeah, after class I will remind them so that you can get in touch with me in Telegram so that we can have one-on-one diet sessions as well. Okay, yeah. So the concave surface of the kidney, this is known as the hilum. So this is the opening through which the blood, the nerves and the limbs enter the kidney. The urethra, everything enters the kidney, right? So inner to the hilum, you have funnel shaped structures. So here you have funnel shaped structures. So these funnel shaped structures is known as the renal pelvis. So renal pelvis has projections known as the calyces. Fine. So before that, I should have started like this, but I immediately ventured into the structure of the kidney. So we are supposed to talk about the human excretory system, right? So this human excretory system consists of a pair of kidneys. So then there's a pair of ureter. So then there is only one urinary bladder and there is only one urethra. So we also spoke about the different nitrogenous waste that our body has to eliminate. So it starts with ammonia, urea and uric acid. So ammonia is the most toxic and it needs a lot of water for elimination. So then you have urea. So higher vertebrates excrete urea as their waste substance, and organisms like birds, they excrete uric acid in the form of pellets. So what are the different structures that is associated with different organisms for the excretion of these? So we had a tabulation that we discussed yesterday, and then we talked about the human excretory system, and now we are into the kidney. Okay, fine. So this is the calyx. So then the inner surface of the kidney is divided into two parts, that is the central medulla. So the central medulla opens into conical shaped structures or pyramid-like structures that is known as medullary pyramids. So these medullary pyramids, so they project through the calyces. So this is the center portion. The periphery portion of the kidney or the peripheral portion of the kidney is the cortex. The cortex runs around the medullary pyramids. So they run around the medullary pyramids. So they run around and it is known as the column of Burney, or it is also known as the renal columns. So this is the structure of the kidney. Okay. So now the kidney is made up of structural and functional unit that is known as the nephrons. So almost we have millions of nephrons in each of the kidney. So nephrons form the structural and functional unit of the kidney. So next we are going to talk about the structure of the nephron. So how is the structure of the nephron defined? So the nephron has two structures. The first one is the Malpighian tubules, which is also known as the renal corpuscle. The other one is the renal tubule. So we have two parts, right? So the Malpighian tubule houses the glomerulus, which is enclosed in a cup-shaped capsule, that is the Bowman's capsule, right? So what brings blood inside the glomerulus is the afferent arteriole, and what takes blood out is the efferent arteriole. So then we have highly coiled structure. So this is the PCT, proximal convoluted tubule. So then you have a hairpin shaped loop, that is the loop of Henle. Again you have a coil structure. So this is not as coiled as the PCT, but this makes up your DCT, and this opens into the collecting duct. right? So this makes up the entire nephron. So now let's do the labeling. So this is the glomerulus. So glomerulus is enclosed in a cup-shaped capsule, that is the Bowman's capsule. So this Bowman's capsule and the glomerulus together is called as the Malpighian tubule, the first part of the kidney. So what brings blood inside the kidney? That is here, it is the afferent arteriole and this is the efferent arteriole. Fine. So this is the PCT. So this portion is the PCT. So this is loop of Henle. So since this comes down, so this is the descending lymph. And this moves up, so this is the ascending lymph. So this is the DCT. And finally, this is the collecting duct, right? So collecting duct opens into the renal pelvis. So via the medullary pyramids and calyces. So this is the structure of the nephron, right? So after this, we went on to talk about the structure that is adjacent to the nephron. So this efferent arteriole, it forms a network of capillaries around the renal tubules. So they form a network of capillaries around the renal tubules. So that is known as peritubular capillaries. So from this peritubular capillaries, a minute U-shaped minute vessel, it runs parallel to the loop of Henle and that is known as the vasa recta. Right? So this is what we spoke. So let me draw it in some other color. So let me draw it in this color. So this is the vasa recta. I hope it's visible. So this is the vasa recta, right? So then we further went on to talk about what are cortical nephrons and what are juxtamedullary nephrons. So your PCT, your DCT and your Malpighian tubules, they lie in the cortex region of the kidney. Sometimes the loop of Henle is not long enough and it is not very lengthy, so it also lies in the cortex region. So such a nephron is known as the cortical nephron. Sometimes when the loop of Henle is long enough that it extends into the medullary region of the kidney, so such nephrons are known as juxtamedullary nephrons. So I guess this is what we have been talking yesterday and I have revised the complete portion of yesterday's lecture. So with this we stopped yesterday. So now we move to the mechanism of concentration of urine. So now with the arrangement and with the structure and the architecture of the kidney well known to us, now how exactly does the urine formation happen? So all of us know urine formation happens in the kidney, right? And we excrete urea in the urine. Fine. So now how is this urine getting formed? So what are the three steps? So what are the paths that is involved in urine formation? So that is the story for today's class. So urine formation, the urine formation happens in three pretty easy steps. So what are those steps? So the three main processes that is involved in urine formation include glomerular filtration, number 2 tubular reabsorption and number 3 tubular secretion. Right? So these are the three main processes that comes for the formation of urine. So now first let's talk about the first one, glomerular filtration. So from the term glomerular filtration, it is clear that the glomerulus is going to play a part. So now let's talk about glomerular filtration. So what is this glomerular filtration? So the ventricles of the heart pump blood. Yes, so I guess all of you now know where the ventricle is. So the ventricles of the heart pump blood. So the ventricles of the heart pump around 5 liters of blood. That is the cardiac output, right? So 1/5 of the blood that is pumped by the ventricle moves inside your kidney. Now the kidney has to filter the blood. right? And who is involved in filtering? That is the glomerulus and the Bowman's capsule. So we have a tuft of capillaries. So this is the glomerulus and it is surrounded by the Bowman's capsule. So this is going to filter blood, right? Yes, so the ventricles of the heart pump nearly 5,000 ml or 5 liters of blood, and about this blood, so 1/5 of this blood enters the kidney and it has to be filtered. So who's going to do this filtration? That is the glomerulus, right? So we know glomerulus is a structure like this. So it is a network of capillary. So it is surrounded by a cup-shaped capsule, that is Bowman's capsule. So this is where the filtration is going to happen. So the efferent arteriole brings the blood inside the glomerulus, right? And the efferent one takes the blood outside. So we don't have to worry about the efferent. So now we're going to talk about the afferent. So blood is coming from the heart inside the glomerulus, right? So now the filtration has to happen. So what are the layers that is going to participate in filtration? So we are going to talk about the layers that take part in filtration. So glomerular filtration happens through 3 layers. So I guess I have done a lot of overwriting on the text. So so these are the 3 layers that's going to take part in glomerular filtration. Okay. So this is the structure. So this is my network of capillaries, that is glomerulus. So this is surrounded by a cup-shaped capsule, that is Bowman's capsule, right? So what brings blood inside the glomerulus? This is the afferent arteriole, right? Okay. So who's gonna get involved in filtration is the endothelium of the glomerular blood vessels. So glomerulus is nothing but a tuft of capillaries, right? So it's glomerulus. So this is nothing but a tuft of capillaries. So tuft is nothing but a network of capillaries, right? So basically it is made up of blood vessels. So the epithelial tissue that form the lining of the blood vessel is known as endothelium. So epithelial tissue is a group or a system of tissue and it also lines the blood vessels. So the epithelial tissue that lines the blood vessels is known as the endothelium. So the first one is the endothelium of the glomerular blood vessel, that is here. Then the epithelium of the Bowman's capsule. The Bowman's capsule is also lined by epithelial cells. So that one, and in between these two there is a basement membrane. So all these 3 layers are going to take part in the process of glomerular filtration. So the epithelium of the Bowman's capsule is known as the podocytes. Fine. So these are the 3 layers and this is how the filtration is going to work. So these are the 3 membranes that is going to get involved in filtration. Now let's see what happens. So how pure is the filtration? So the epithelial cells of the Bowman's capsule are known as podocytes. They are arranged intricately to leave some minute spaces, that is known as filtration slits or filtration pores. So you would have seen your mom have a filter. Sometimes she used to filter milk, sometimes she used to filter juices. So we used to make chai with the filter, right? So how is the filter? So it has very minute pores, right? So it has a lot of pores, right? But here the podocytes, that is the epithelium of the Bowman's capsule, have this slits of the pores at definite intervals, right? So this slits of pores is so perfect that when the blood is filtered, so blood has a component known as plasma and the RBC, right? Obviously the RBCs are the formed elements are thick solid portion, so that will not be filtered. So how about the plasma portion? So when I'm filtering, plasma is the liquid portion, so it should get filtered, right? But the plasma proteins are also not filtered, so the filtration slits are so accurate and so perfect that even the plasma proteins are not filtered, right? So this makes the filtration very accurate and precise, and hence it is known as the ultrafiltration. So almost all constituents of the plasma except proteins pass the lumen of the Bowman's capsule, and this is ultrafiltration. So the first step in the process of urine formation is glomerular filtration. So your glomerulus is going to pump or filter 1/5 of the blood pumped by the heart. So who is going to get involved in the layers or in this process of filtration are the 3 layers. endothelium of the blood vessels, that is in the glomerulus. Then you have the epithelium of the Bowman's capsule, that is the podocyte, and in between these two there is a basement membrane. So now how is the filtration? The filtration is so perfect that it is called as ultrafiltration because the podocytes of the Bowman's capsule have filtration slits which does not even allow the plasma proteins to pass through. Fine? Okay. So now moving further. So the filtrate that comes out of the glomerulus is known as the glomerular filtrate. So after the filtration process, the product that comes out is the glomerular filtrate, right? So GFR stands for glomerular filtration rate. So how much is getting filtered in a particular time? So rate is with respect to a time, over a span of time. So whenever rate comes, the time is mentioned there. So in a year, in a week, in minutes, in hours, etc. So that is rate, fine? Okay, so the normal GFR rate is 125 ml per minute. So per minute your glomerulus filters 125 ml of blood that is pumped by that is coming from the heart. Okay, so this is per minute. So then how about in a day? So it is 180 liters per day. Oh my god. So your kidney has to be very efficient because 180 liters per day it keeps filtering. So that's amazing, is it? Fine. Suppose let's say this GFR rate, that is the glomerular filtration rate, has fallen down or it falls down below the normal value. So ideally you should have 125 ml per minute. So what if the person has only 100 ml per minute? So the rate is less, right? So then who regulates it? Who repairs it? Who brings it back to the normal? So there is a mechanism of regulation that is inbuilt, that is within the kidney itself. So in the junction between the afferent arteriole, and the DCT, that is the distal convoluted tubule, there are a group of cells that is known as the JGA cells. So JGA stands for juxtaglomerular apparatus. So there are a group of cells called the JGA cells which activate angiotensinogen, So angiotensinogen is an inactive form. So this is getting activated into angiotensin 1. And further into angiotensin 2. So now this angiotensin 2 further activates another protein, that is renin. RENIN. RENIN comes in digestion, but RENIN comes in the kidney. Now what does this do? Hold on. So here my GFR rate is less, right? So which means the pressure is less and the volume is more, right? So pressure and volume are two different things and they are inversely proportional to each other. Fine. So here my pressure is less, so the volume is more. So when the renin is released, so this increases the pressure and it decreases the volume. So renin is a vasoconstrictor. So vaso talks about the blood vessel. So constrictor means it constricts the diameter of the blood vessel. Okay? Yes? ओके मैम, कभी कभी हिंदी में भी एक्सप्लेन कर दीजिए, ऐसा इजी हो जाता है समझना. ओके फाइन. बट ज्योति, थैंक यू for joining my class. So please do like, share and subscribe. The problem or the reason why I don't shift between languages is because it is completely English medium. So the eCareerPoint also has a Hindi medium channel. So I don't come in that channel. So this is an English medium channel. So that is the reason I speak completely in English. So if you want me to slow down and if you want me to use terms in Hindi, yes, let me know. I can do it for you. Okay? Yeah. So this is how the kidney regains or regulates the GFR. So once again, GFR is back to its normal rate. Fine? Yes? So what gets activated? Renin. So renin is a vasoconstrictor. So once again, the GFR rate is back to the normal position. So far we have been only talking about the first step in the regulation, right? So, sorry, in the formation of urine, that is glomerular filtration. So the first step, I guess, is clear to everyone. So what is glomerular filtration? Yes, Bhavya, S. Supriya, Dharni. So how is glomerular filtration happening? Is that clear? Yes? Okay. So now we move to the next one, that is tubular reabsorption. So what is that next step? Tubular reabsorption and secretion. So let me tell you, so your kidney almost pumps 180 liters of blood a day, right? But how much of urine do we excrete? So in a day, hardly we excrete 1 to 1.5 liters of urine, right? So what happens to the remaining 99%? So where it is going? It has to be reabsorbed. So who's gonna reabsorb and where it is getting reabsorbed? Let's talk, okay? So that is reabsorption. So 99% of the filtrate is reabsorbed by the renal tubules. So after the glomerular filtration, the end product is the filtrate, right? So we are going to reabsorb certain things from the filtrate. So we do this, no? So first round, we clear all the dust in the rice or the wheat. And the next round, again, we do a cross-checking. So this is called drafting in technical terms. So that's what your kidney is also doing. So first it filters the blood. Then it tries to reabsorb whatever is essential. So first you clean your room. You are very angry. So you clean your room. You take out all the dust and throw it. And then you sit down with the dust and you see which you can filter so that you can keep it still, right? So we have this habit, right? So that is what your kidney is going to do, is your kidney is going to reabsorb, okay? So it's going to reabsorb certain things from the filtrate. So either by active or the passive mechanisms. So reabsorption happens from the filtrate to the renal tubules. So reabsorption. So this happens from the filtrate into the renal tubules. Fine? Okay. So whatever is needed is getting reabsorbed either by active transport or passive transport. So active transport needs ATP and passive transport needs no ATP. Right? Okay. So urine formation, okay, so this is reabsorption. So we reabsorb everything. So we reabsorb sodium, we reabsorb amino acid, we reabsorb glucose, so whatever. So we reabsorb water as well. So water is reabsorbed by diffusion. So everything we try to reabsorb from the filtrate so that the level of the filtrate comes down. Fine. The next step is tubular secretion. So now that we feel very bad, we take everything from the filtrate, we want to give back something, right? So that is what we are going to do. We are again going to give back. So now that you have cleaned your room, you are in a very angry mood, you have cleaned your room, you have thrown everything outside, but then you sit and take out the things you can still keep, right? But again, you feel you have taken a lot of dust with you, so you want to throw it again, right? So that is tubular secretion. Now your renal tubules feel that they have taken up all the things that is available in the filtrate, so they feel very pathetic. So they now give back to the filtrate, right? So that is secretion. So secretion happens from the renal tubules into the filtrate. So you should know from where it happens. But why is secretion happening? To maintain the fluid balance in the filtrate, right? So the filtrate also has a pH, right? To maintain the particular fluid balance in the filtrate, now your tubules are secreting something. So what it is secreting? It is secreting H+, K+ and ammonia into the filtrate so that it maintains certain condition. So these are the three steps in the formation of urine. First is glomerular filtration, the glomerulus filters, right? So now that it filters more, so we are going to try to reabsorb everything from the filtrate. So now we reabsorb almost 99% of the filtrate. Now, to maintain the balance of the filtrate, we are secreting certain ions so that it stays in a particular concentration. So now your urine is formed. Right? So the end point or the end result of all these three steps is the formation of the urine. Okay? So now finally your urine is formed. But when you don't drink enough water, your kidney has this responsibility to conserve water. So in a day, it's a myth that you should have so and so liters of water, not necessary. So you should have the amount of water that your body needs. That is all it is, right? So it's not necessary you have to have so and so liters of water. That is a myth. So you need to have the amount of water that your body needs alone. So whenever your body is in need of water, your body knows how to make sure that you drink more water. So that is when you start feeling thirsty, right? Okay. So, but when you don't drink enough water, but your body is in need of water, so your kidney has this responsibility to control or conserve water, right? It cannot let a lot of water get excreted through the urine. So how does the kidney then concentrate the urine? That's when the urine becomes yellowish, right? So how does that happen? How does the kidney concentrate urine? So that is the story for tomorrow. But before tomorrow, we talk about the mechanism of concentration of urine. So we'll also talk about the function of each tubule. What is the role of each tubule? So what does PCT do? What does DCT do? What does loop of Henle do? So we are going to talk about the function of each of the tubule, and then we are going to talk about the mechanism of concentration of filtrate. And finally, in the last lecture, so we'll be talking about micturition, the process of release of urine. So how does it happen? Fine. So with this, we are done with the mechanism of concentration of filtrate. I hope I have explained it to the best. So if you guys have any doubt, you can put it forward. Yes, Supriya. Yes, Bhavya, Dharani. So any doubt? So should I explain once again? So is it clear? Yes, anything that you want me to explain once again? Yes? Nothing? So it's all perfectly clear? Well, then this is my last slide, so I don't have a slide after this. So if you genuinely liked my way of teaching, so please do like, share and subscribe. So it gives me a lot of pleasure and enthusiasm to connect with you every day. Yeah, thank you Supriya for the response. So this is me wishing you more and more. So tomorrow at 5:15 p.m. I'll meet you with another topic. So until then, stay tuned and take care. Bye.